Okay, everybody, so today we're going to start, we're going to start talking about what we're going to do for the whole rest of the semester, which is waves. So light, color, sound, and a little bit of Einstein, I hope. We can get a little special relativity in there, so we're just going to be talking about waves. And the start of that is we're going to talk about the source of all waves, and all waves come from vibrations. Let's see if I can't tilt this down a little bit. Okay. Get the pendulum on there. And this is a pendulum, and I think you've seen them somewhere before. Maybe you've seen one at like the State Museum. They've got that big one that hangs down from the ceiling, and maybe a grandfather clock or something. And so they were originally used to tell time, and they make very accurate timing devices. And so for a pendulum, it would swing back and forth, and at the top it would be connected to a gear, and hopefully swing back and forth in something even and neat, like 1 second or 2 seconds. And then every time it swings back and forth, the gear it's attached to at the top would then turn the second hand 1 time. But that means that your pendulum has to be tuned properly so that it actually swings back and forth in a second. And what we're going to do, I'll time this one. We'll time the period of the pendulum or a complete cycle. So we'll start from one side, let it go back all the way to the other side. And that's 2.9 seconds. So for this pendulum, it takes 2.9 seconds for it to swing back and forth 1 complete cycle. That's not a very good clock because it would be attached to a gear, and that gear would turn the second hand once every 2.9 seconds. That's an extremely inaccurate clock. So we want to be able to find a way that we can adjust this pendulum so that it actually swings back and forth much more quickly than that. Okay? In a second would be good. We can do different things, and what you're going to do is, there on Canvas is the lab paper, the Pendulum Lab, and we're gonna collect some data, and I'll collect the data today in class. You'll fill out the lab report, and then you'll do the graphing and answer the questions, okay? And if you've already done that, we're gonna think about the things that we can do to change this. Remember, it swings back and forth in a certain amount of time, and we want it to actually swing back and forth in a precise amount of time. So we want to be able to adjust this. And there are different things we can change, like right here, I have a 1,000 gram or 1 kilogram mass hanging off the end, and it gives us a certain period, a time it takes for it to cycle back and forth. Well, I can certainly change that. Here's 1,000 grams. I can half that and make it 500 grams, and I can swing it back and forth and see what the time is. And I can lower it all the way down. I can do more, but this is a 200 gram mass, 0.2 kilograms, and I can let it swing back and forth, and I can time the pendulum and see what effect changing the mass has. I can also change the length. Instead of down here at 2 meters, I can make it maybe a half a meter, or that's 1 meter, sorry, and I could make it, I already have a knot up here for a half a meter, and I can let it swing back and forth, and I can time the period. So I can change the mass hanging on the end, I can change the length of the pendulum, I can also change the angle of the pendulum, okay? So I can start it from straight up and down. I can maybe go to 10 degrees out, or any degree that I wanted. But your lab report says at 10, 30, and 45, so I can go up to maybe 30 and time how long it takes for it to swing back and forth. I can go all the way out to 45, and I can time to see how long it takes to go back and forth, so that we can figure out how we can change this pendulum to change its time, the things that we can do. So we can change mass, we can change angle, and we can change length. And remember, when you're doing an experiment, you're collecting data, you only change one of those things at a time. So on your lab report, turn the brightness up a little bit here. We have masses of 200, 500, and 1,000 grams, lengths of half a meter, and 2 meters, angles of 10, 30, and 45 degrees from straight up and down. There's 3 trials of each, but what I'm gonna do for your lab report is I'll just take one timing for each of these, write those down, and then you'll plot the data. But here, let's start right where it says we'll start with the mass. And the first one is a 200-gram mass. And remember, since I'm checking mass, I'm gonna pick one length and one angle and not gonna change those. So I'll go ahead, put that down there, and I'll just pick an angle. I'll just eyeball it over a spot on the floor. So this is timing the period of the pendulum with 200 grams at 2 meters, and I'm not gonna change the 2 meters or this angle. So let me let it go, and I'll start it from there, all the way back through a cycle to there. 2.9 seconds, all right? Okay, so mass of 200, remember I'm not doing all the trials, I'll just say that I'm perfect at timing, and I did it for 2.9 seconds. And so now I'll change it from 200 grams, it's in your paper, the next one is 500 grams, so I'm changing the mass to 2.5 times as much as I started with. And I'll start over here at the same basic angle, and we'll start it there, and go to there. So that's 2.9 seconds again. It doesn't seem that mass is really working out to change anything. When I had 200 grams on there, it took 2.9 seconds. When I had 500 grams on there, it took 2.9 seconds. Doesn't look like mass is having much of an effect on the period of the pendulum. If you think about it, if you remember back when we talked about gravity, gravity accelerates all things at 9.8 meters per second squared. It doesn't matter what they weigh. So this should kind of make sense that mass doesn't really have an effect on it, but I've moved over to the 1,000 gram mass, and I'm gonna let it go, and I'll time one complete cycle from there all the way back to there, 2.9 seconds. So it seems that changing the mass does not change the period of the pendulum. That's kind of counterintuitive. Most people normally think that if you hang something heavier on it, it should move faster. You remember Galileo, we talked earlier about how if you drop 2 heavy things of the same shape and size but of different masses, it doesn't make any difference. Turns out you could hang something that weighs 1,000 pounds off of this pendulum and it won't change the swing of the pendulum. It'll be the same amount of time. So right now, as I'm looking at this, mass doesn't seem to have any effect on how fast the pendulum moves. We'll go to length here. Remember, we're changing length, we're checking length, so I'm gonna pick one angle and one mass, and I'll just use 1,000 kilogram. And we'll start, the first one is a half a kilogram, so we'll put it up there. So clear out the stopwatch, and I'll pick one angle, and I'll just pick a spot on the ceiling to measure, so that I won't change that. Let it swing back and forth. So that's 1.4 seconds. Well, it looks like changing the length has had an effect on it. So we'll go down to the 1 meter length, clear out the stopwatch, go to the same angle. And about 2 seconds. So right now, length looks like it's having an effect. And we'll go down to the 2 meter length, although we already did this length once before. Try to keep the same angle. And we'll time one complete cycle from there to there. 2.9 seconds. Okay, so right now, the length certainly having an effect. The mass had no effect, but the length certainly did. Really short half-meter pendulum took 1.4 seconds, and then as the pendulum got longer, the time it took for it to swing swing through a complete cycle took longer. So if we wanted to have a clock that took 1 second to go back and forth, it looks like it certainly needs to be less than half a meter connected to a gear that would turn that second hand. And now let's do the last ones. We'll check angle, 10, 30, and 45. Try to do this quickly. So I'll swing it back through. It's about 10 degrees. And we'll time it from one end through a complete cycle back again, 2.9 seconds. And then I'll go to about 30. I'm not measuring exactly, just for time, but certainly it's a much greater angle. 2.9 seconds. All right, so it certainly looks like the angle is not making much of an effect on it, so we'll come out to about 45 degrees. Let it go, and we'll time one complete cycle from there. 2.9 seconds. Wow. Okay, so let me stop that before so if you look at it here, the mass had no effect, and that should kind of make sense because gravity accelerates all things at the same 9.8 meters per second. So, and gravity is what drives the pendulum, so mass shouldn't have an effect. Angle, you might think that angle has an effect because it certainly has a lot further to go. The greater the angle from the vertical, the much longer distance it has to travel. But you'll notice it goes much faster, so gravity has longer time and a longer distance to accelerate it and get it going faster and faster. If you do it from a really small angle, like we did 10 degrees, it has a much shorter distance to travel, but gravity has much less time to accelerate it, so it never gets really going very fast. And it turns out it works out perfectly. This shorter distance at that slower speed gives us the same time as a longer distance that has more time to accelerate and a much greater speed. So it all works out evenly. So here, let me get you up here so you can see the data as written down. Hopefully. Well, I'll put it over here somewhere. Okay, so this is the data for your lab, and you'll graph this. So for each graph, you're going to be doing angle versus period of the pendulum, mass versus period of the pendulum, and length of the pendulum versus the period of the pendulum. For all three masses, it was 2.9 seconds. For all three angles, it was 2.9 seconds. For length, the half meter was 1.4 seconds, the 1 meter was 2 seconds, and the 2 meters was 2.9 seconds. So there's only going to be 3 data points on each of your graphs. Draw your best fit line, but you're going to see that 2 of them are just, the 2 that had no effect are going to be a zero sloped best fit line because mass and angle have no effect. But go ahead and answer those questions on there and get that lab submitted, and we'll do some stuff. We're going to do some slinky stuff here in class. We have really long slinkies to make waves on, but we'll do that another day. So get this lab done and turned in, and that'll be it for today. Bye.